All right, everyone, I'd like you to take a quick look at page 8 of the book that I just handed out. This is a graph that's given to you that was an actual numerical response question on the diploma exam. You will see one of these on your diploma exam next week. You will see a graph given to you where you have to find the slope of that graph, find the y-intercept perhaps of that graph, and then use the slope and or the y-intercept to get something. We're going to do this example here right now for two reasons. One, to refresh your memory as to how to analyze a generic graph, whether it's a graph you've seen before or a graph you haven't seen before. But two, to also refresh your memory on how to use the calculator to get the slope of the y-intercept. I don't want you to draw a line of estimate on this graph. I don't want you to calculate a line of estimate. That's a useful skill to have sometimes. It's not a skill you need to have for this exam. For this exam, you need to get, that's a generic response, you need to get the number that they expect you to get. You may get that number if you do by now. Or you may be off by a tiniest little bit if you get it wrong. So what I'm going to ask you to do, so what can you do this example? We'll go through this example of A, finding the slope of the y-intercept, and B, what we do with that slope of the y-intercept. You can see in that question it says, essentially that we've got a lens system here, which we experiment for our lens experiment that we did. We get a graph, in fact, it's very similar to the graph that we saw. We get the reciprocal of the image distance versus the reciprocal of the object distance. You can see that it works out to be pretty close to a straight line. Pretty close to a straight line. Although not perfect, we do have some data points right now scattered a little bit. You have to figure out what the slope is. You have to figure out what the y-intercept is. You have to figure out what the value of the slope and the y-intercept are. Here's what I want you to do right now, please. Please turn to page 10 of that book. Page 10. So, remember we flip the page, not on the next page, it's on the back. Page 10 of that book. On page 10, the physical instructions are plotted graphically. I'll show you this in class already. You guys see the extra already? Wow, that's fantastic. But, if you pay attention, it's easy. And work through a couple examples of it at home. So you're good at doing it. Okay? You're not going to have the instructions on so it should be easy to be done a few times already. What we got to do here, guys, is put our data points into our calculator to get the slope of the y-intercept. So here's how we're going to do that. We're going to go to stat, follow along the instructions here on page 10. So stat, then we're going to go to edit, so edit, option 1, edit. We're going to enter some data points. There's data points in my calculator already. I want to delete those data points. That's clear. There we go. That's a block button. Clear them all. If you want to clear them all individually, that's fine. That shouldn't really be an issue actually. You guys have to focus on it. Because the memory is going to be clear. You shouldn't find that there's anything in there already. You shouldn't have to do that process. You don't have to do it. All right. Now we got to find the data points on this graph. Now the only challenge here really is not applying and doing what we committed, but rather getting the actual data points. So let's pick those data points now. My x coordinates, looks like my first x coordinate is 0.65. 0.65. Go to my second x coordinate, looks like 0.85. My third x coordinate looks like is 1.0. My fourth x coordinate is 1.15. And my fifth x coordinate is exactly 2. All right, so I've got all my x coordinates. Now I'm going to do my y. Here's how to do this. The first y coordinate is 3.2. The second one is 3.1. The third one is exactly 2. The fourth one is 2.6. And the fifth one is 2. Okay, got all our data points in. We're ready to plot this graph. You know what? That's a lot. We're not going to plot this graph. All we're going to do is get the statistics for it. We really need to see that. Let's see from this already. Let's do the stats for it. It's stat. All the instructions. It's stat. We're going to count. over to option 4, to refresh, and let's press enter. Press enter again. You see the slope here. Slope is equal to negative 0.95. And the y-intercept is equal to 3.2255. Now, we just finished part of the expression. The first part of the expression says it's value of the slope of the line, negative 80 decimal b. Given my first two boxes, 0.9. Does that make sense? 0.9 is my slope, so I fill it in as 0.9. Now we got to figure out. I'm going to figure out the forward. Whatever the intercept, they tell you to use the y-intercept. I would do that. How do we do that? We go through this process all the functions. Straight line. Why is it in the y-axis? One over and is the slope. X-axis is 1 over O. Plus, I'm not going to scratch off that y-intercept this time because clearly there is a y-intercept. Just looking downwards. Now we got to get an equation that appears on our dash. It's two variables. That equation is 1 over L. It's equal to 1 over O plus. We want to rearrange that equation. Take it to form. In other words, solve for 1 over the L. Solve for the C variable. It equals negative 1 over O plus 1 over F. Now, I could have said 1 over F minus 1 over O. Why did I realize to pick that up? Yeah, it's fine. I wanted to do this picture. I wanted to see more of that. That's the path. It's easier to spot what you want to spot. I'm suggesting rewrite exactly the same one. We're going to cross up this over the eye. The over here. We left with the slope is equal to negative 1. No, we got negative 0.925. That's pretty close to 1. So theoretically, on point axis, the y-intercept therefore that is 1 over 3.255. We want our answer what? It said it was, we're going to convert that to 26. My last two boxes. 0.926. Now they will accept a small range of answers for the first two with the slope and the second two with the slope. They will accept 4 or 5 possibilities. Accept all this is 4 possibilities. But if you're on that line, that's the question. It's tough. Exact number or not. Quite tough. A, guarantee to get an exact answer. Yeah. It's easier to try to set it done. You guys comfortable with this technique? We use that a lot. All right. I want to see what we got. Now I want to talk about this. You're going to get one of those questions. Very deep. You don't know what graphics are. You go up to the graphics form. That happens. I say 80 to 50% of the time. So unlucky, let's take the graphics. Again, you don't graphic you have to form. Don't set a site. And again, someone who is something that could have been very ask questions. You will see a question that's going to be asked to solve. Following that up, we're going to ask you to list the physics principles to solve. Now, I can list the physics principles to solve it. In other words, basically, try to show the work a little bit on a numerical response. You take a look at the bottom left-hand corner of your data sheet and a part of the book. Look at your data sheet. Fill it out. That's what you're going to be looking for. Steps. Bottom left-hand corner of your data sheet. You're going to see 10 physics principles. They're listed 0 through 9. First, I was saying questions on the exam. As soon as I saw that, I thought, oh, this is perfect. They don't need to be able to do it. They always tell you, I'm going to give you some semester answer. They always tell you, section 2, the answer to this question. They think, it's the answer. It's the 10. But they go on that. Check that, line down. So they switch it to 0 to 9. Now it's always going to be a 2-digit answer. That's great. Then it gives you some choice. Which two you're going to use. I promise you, the 3 legitimate principles you use, and any combination of 2 of those principles can't get it correct. What are the principles? Well, 0 is uniform motion. In uniform motion, uniform motion, that means you have 0. Balanced forces, balanced forces. Basically, you take what you need to use the balanced forces. You use principles. So if you use that equation, it's a constant speed. Forces are balanced. You know, like getting say the building oil box when it's suspended, or it's moving at a constant speed. We know we're going to use uniform motion. Accelerated motion, and it's not inclusive. In other words, it's accelerated when you have to be right? It speeds up and slows down, and so on. Uniform circular motion, basically, it's based on the square over R, or x with an empty square over R. We use uniform circular motion. One of the most common places we see that one would be the magnetism motion, or very far from the circle. Uniform circular motion. The word energy theory basically says that means you're going to at some point in the question, setting the change in kinetic energy of that people to work done on the object in order to there's 4 concepts, right? Yeah, one, two, three, four. Conservation of energy. Why? That could appear as a change. The car going downhill, right? But it could appear as a chart model of speeding up or slowing down. It could appear as, you know, electron colliding with something, transferring its energy to constant control problems. But as long as the total energy has to be that's constant. Yeah. Conservation asset. Talking about balance. Use that equation. Seven concentration of charge. Not so much math, not so much equation. Concentration of charge is like that. Your charge has to stay the same. Maybe you touch 2 things together. One is +5, the other is -5. Balance would be 0. That's concentration of charge. Maybe if the neutron is picking up the proton and then the electron, that's concentration of charge. Right? Total amount of charge is 0. The total charge is changing after something happens. Concentration between ions. You know, Yes, conservation of finally, a part of the valley, um, particle feature of white light, or big nature, or what you often see that associated with this. We're talking about light, which is a frequency wavelength, but photon theory, particle nature of that wave. I think these all make sense, right? We've seen all these before, nothing new, it's just a matter of making sure that we're on the right track to see which one to use or something like that, right? Is number 9 the same as that? No, I would say that's well, you can probably argue that it's about it. It's about it. That was the first thing that I looked at. I probably think that okay, I want to do an example. You're going to find that the example that we're going to do here, please keep your book, I can't remember which page it is. Actually, let's talk about this. The two other ones is solution. That's the first one. Just to look at which one we do. All the ones that I put in this booklet are harder than average. Now, it doesn't mean you can't get one that's hard, but it does mean that normally you're not going to get hard. I think all ones are hard because I thought, well, it's just electrons are started from rest by electric potential differences. They're volts. Right away, when I read that sentence, it's got to be active in our reading. We can be active in our reading. Electrons are accelerated from rest like that. I don't need to go any further in this question. Let's spot something. Electrons are accelerated. Electrons are speeding up. Pretty good. Equals yeah. Conservation energy. It's a car going down a hill, right? Where do I get down? Whether or not that helps me or not, I'm not sure. But I know that I can do this. These electrons enter a region that can be too perfectly directed in the field. There is a word here. This is stated grammatically correct. But if we read the line, we'll see that word. Electrons then enter a region. Right? It's happening after the accelerator. So that's something different. We've got something happening. Then we've got something else happening. Then enter a region. Now, I'll be honest with you. When I looked at that sentence, I really think the last section. You're not going to get a field. They don't know this. They don't know what the points of that. It looks like a certain combination of gravel with circle is caused by I don't know what I call that. It's a combination of gravel. So if you ask that question, right. So we got this electric field, we got this magnetic field after it's accelerated. So basically, EI equals EF right here. So we got electric and magnetic field. Let's talk about that. We really know the question. That's okay. We're all three on the diagram because we got two forces out there, the electric force and the magnetic. We got negative charge particles. They will experience the electric force toward the positive charge plate. They will experience the magnetic force from meters all points down to the negative charge plate. At E equals at By the way, this is an older version of the structure. Now they put like that. You can be able to answer the first question already. Next slide. I don't see conservation energy, sure. And that's principle, what is that, principle 5? Sorry, small one, so it's 5 and 1. You can throw that in as 1, 5, or you can throw it as 5, 1. Doesn't matter. You just have to throw it in a particular order. Now they don't make it still in. Don't come across the next step. So always. So we just got one of these two questions. We don't ever have actually done the question.
Did I say that before you just
I don't know. That's a little bit. They actually still, as the last example I saw, the last semester, they actually still said that, but they said it doesn't matter. So basically, they're trying to get you to do it for that's not what I will. We get it right. You don't want to ever have done anything. All right, now let's solve the cases for sorry, first answer for me. Now when I look back and say that's a good thing for everybody diagram. I want to find the acceleration, right? Energy, you need these force. Magnetic force, of course, the charge pencil. That's the electron. The acceleration. Charge. 8.5. 5. And that's positive dot, right? That when you write the force, positive dot, you can see that. What's QDV? 1.6 times 10 times speed, which, oh, wait a second. No, it's stretch. How fast is it moving? When it enters its place in the magnetic field. You notice that first is red, you guys see that. We're going to get C at the end of that. It's going to be Q times E, not 2E. One out of the square. 1.6. That's what I'm going to say. So, P, because the difference is 300 volts. It's 1.5 of mass. 50. My guess is going to be 6 somewhere there, from the 5 to 6. Okay, those students a little faster than I would predict. It's so awesome. Okay. I should not like that. I remember it. Before you develop. I'm going to take that number, plug it in here. Now I'm going to put your piece aside. We multiply that by D, magnetic field, which is 0.26. Okay, right there. For oh, well, you know what? If I remember actually, it's 6. Yeah, it's 6 in the. Well, here's a 6 in the negative number. Yeah, this is a different format. No, it is a positive. So, we're not putting acceleration to the bar. That's the typo. And I guarantee you that it wouldn't feel like the former section. Yeah. You can have there physically water. Direction they like to feel that? Yes. It's that's a good question. The direction they like to feel that? And the answer is yes. Direction they like to feel something positive. The force, it's opposite. You tell this force that out. There's a plug in here? No. Be there on the direction of force, plug in not the direction. What did you do? Oh, I see. That is now. So this is a BCP. Look at that expression. Wow. Express that as Q1. Now, I don't think that any of us would disagree with this. That's hard enough. I think it's something you can get that question. But it's not question. Bottom line is this. Usually the questions seem like this isn't as hard. If it is, you can still get the first one. You may not get the principles until after you solve it. You have to go back and get the principles. Or you may not ever like this question. I always tell you, like, watching your time to answer. 3 minutes per question is the max time. This question is going to take you 15 minutes. This question is going to take you less time. So what I want to do is next look at it as a whole. The question together and say, yeah, it's easy. You know what? It's even okay if you go over 6 minutes a little bit. I would say this. Any questions? Okay, that's everybody. Get this question. I don't know what it's quite possible. Get this question, guys. And it's a challenging question. You think it's going to take you more than 3 minutes or so? Skip it. This part of the question. That is not what the hard ones, the ones that you may get wrong because they're just really tough. Those are the ones you don't want to know. Don't know what it's like. I'm sure it's a hard question. Don't just look at questions necessarily for it. You're in the middle of it. When you come to a challenging question, skip it. It's a start. Go back. The whole thing is not back to it. You don't. It's better that you skip that one, the one that you have a pretty good chance to get wrong anyways. Then you really easy question and that's that never is great. That's it. So all caps might have to see this hard. I'm sure. It's a lot of things. But it's a little bit hard. It's about a little bit exam. It's 2.5 hours long. I'm not the first time. I'm not. It's already great. You know. Oh, that's the thing. Yes, clear on that question. Um, my question right now is, what do you think about the format? That's not. That's not. I'm going to say that for the last thing. What's the question? I think it was that. Let's see, if I was to withdraw, I'm not sure what we're going to do. It's pretty good. It's strong. But I mean, always, I was good. I tried to get that. That's okay. All I know is you have to throw that question. And even after you study, you have to throw that question. All that tells you is that, you know, that's like 19, 18.5 years before one person in the school is gone. So guess what? You're pretty good company. You're pretty good company. That's well, if you dig it on there. Dig it on there. And we will name what is in June, every June 25th. You're on all, not all. It'd be a day named in honor. I'm preparing next year. That's all next year. We're going